Good afternoon, everyone. My name is Philipp Allgeuer. I'm from the University of Bonn, and I'm here to talk to you today about fused angles and the deficiencies of Euler angles. Fused what? I hear almost all of you ask. Well, I'll get to more details on that later, but fused angles are, simply put, an easy way of quantifying 3D rotations, just like Euler angles are, but a way that has been specifically developed for mobile robotics and solves numerous problems and imperfections that Euler angles have. Also more details on that later. So, suppose we have some general 3D rotation, and we have three boxes in which we want to write three values. Together, these three values should quantify the rotation. We're going to refer to these values as yaw, pitch, and roll, and would like these values to relate to the amount of rotation, whatever that is chosen to mean, about the z, y, and x axes. For ease of interpretation, the values should just be angles, so radians or degrees, and loosely speaking, as a result, we should expect that bigger values will lead to bigger rotations. That's all pretty simple so far, and in my personal application of bipedal walking, you can easily see how something like this would be useful. It is not entirely uncommon to treat the lateral and sagittal planes separately, and for feedback purposes, it is then useful to be able to answer questions like, how rotated is the robot in the sagittal plane? How rotated is the robot in the lateral plane? What is the heading of the robot? So, looking at our standard rotation representations, clearly only one of them could possibly do what we want. But the answer is actually not really. There are problems, as discussed in detail in my paper. My answer to these problems is fused angles, which defines fused yaw, fused pitch, and fused roll components that do exactly what they should. Fused angles were first introduced at IROS 2015 in my paper titled Fused Angles, a Representation of Body Orientation for Balance. And in that paper, I did summarize the problems with Euler angles, but overlength pages are expensive and it would have required far too much space anyway, so essentially my argument boiled down to just trust me. So, now I'm here to do it right. The paper I'm presenting today does a full analysis of Euler angles and fused angles, and why these and demonstrates in detail what the differences are and why these are so important. So next time you feel tempted to use Euler angles just because it's the standard solution to use when you think there are no alternatives, maybe, just maybe, you'll think again. Thank you, and come talk to me in the interactive part of the session to find out why.